Okay, so we're starting on workbook page 390. We're going to compare and order rational numbers. So a rational number is any number that can be written as a fraction. So that's terminating and repeating decimals. If you have a decimal that goes on forever and does not repeat, then that is called an irrational number. So that's like if you had a decimal that went on with no pattern, like just something random forever. But if it's a terminating or a repeating decimal, then it is a rational number. So the directions say, fill in each circle with less than, greater than, or equal to make a true statement. Number 1, 9.7 is what to negative 10.3? Because 9.7 is positive, positive numbers are always greater than negative numbers. So we would put the greater than symbol. Number 2, 5/8 is what to negative 3/8? Same thing, 5/8 is positive and negative 3/8 is negative. So positive numbers are always greater than negative numbers. Number 3, negative 6.7 is what to negative 6 7/10? So the easiest way to compare is you want to make them both into decimals. So I'm going to take negative 6 7/10 and we're going to make it into a decimal. So negative 6 is the whole number, so that's going to stay in front of the decimal. Now to get what goes behind the decimal, we have to do numerator divided by denominator. So 7 divided by 10. And 7 divided by 10 is 0.7. So the whole thing equals negative 6.7. So these two are equal. Number 4, negative 5/6 and negative 0.94. So again, let's make this into a decimal by doing numerator divided by denominator. And we don't have any whole number in front of this like we did here. So everything's just going to be behind the decimal. So this is 0.83 and the 3 is repeating. So we put our bar notation on top. And this is negative. So we have negative 0.83 compared to negative 0.94. Now, if these were both positive, 0.83 would be less than 0.94. But when they're both negative, it's the opposite. So 0.83 is actually greater than negative 0.94 because it's more to the right on the number line. Number 5, order the following sets of numbers from least to greatest. So again, the easiest way to do this is going to be to make them all decimals. So negative 3 1/3, we're going to do negative 3 points because the whole number goes in front of the decimal. Now we're going to do 1 divided by 3. And 1 divided by 3 is 0.3 repeating. Then the next fraction we have is negative 3 3/4. So again, the negative 3 goes in front of the decimal. Then we do 3 divided by 4, which is 0.75. So now we've made all of our fractions into decimals. Now to compare them, you want to make sure that they all end with the same amount of numbers behind the decimal. So this number has 2 numbers behind the decimal. So we want to make them all have 2 numbers behind the decimal. So negative 3.3 repeating would become negative 3.33 when we make it 2 numbers behind the decimal. Positive 3.3 would be 3.30 because there's no number that comes after that 3, so you could put a 0 there. We put a 3 here because this is repeating, so the number that would come next is that. And then for 3.5, we'd have 3.50 if we add a number behind it. So now that they all have 2 numbers behind the decimal, you can compare the numbers really easily. So we have 2 negative numbers. So those are going to be the least, so we should look at those first. Negative 3.33 and negative 3.75. So negative 3.75 is the least, which was negative 3 3/4. Then negative 3.33 is the next least, which was negative 3 1/3. Then 3.3 would be the next least. And then the greatest is 3.5. So that's the order from least to greatest. Number 6. So order from least to greatest, let's make any fractions into decimals. So 2 and 1 over 11 would become 2 point, and then we have to do 1 divided by 11, which is 0.9 repeating. So now let's make sure that they all have the same amount of numbers behind the decimal. So this is 2.1 repeating. So if I add one more number behind the decimal, there should be another 1 because it's repeating. Negative 2.1 is going to become negative 2.10 because there's nothing that comes after that 1, so we put a 0. And then negative 2 is just a whole number, so negative 2.00. So now let's look at the negative numbers first because we want least to greatest. So negative 2.10 is going to be most to the left, so that's the least number. And that was written as negative 2.1 originally in the problem. The next least is going to be negative 2.00, which was originally just negative 2. Okay, then we have our positive numbers. So we have 2.11 and 2.09. So this is like 2.9 and 2.11. 9 is less than 11. So 2.9 is our next least, which was 2 and 1/11. And then lastly, we have 2.1 repeating. So this is least to greatest. Number 7, Steve recorded these amounts in his checkbook. Order these from least to greatest. So let's look at the negatives first. Negative 6.50 and negative 6.75. Negative 6.75 is less than negative 6.50. So negative 6.50 is the next negative number, so that's the next least. Then we have 7 and $7.25. So $7 is less than $7.25. So this is our order from least to greatest.